Right, welcome everybody to the end of DockerCon, and we've done you all an absolute solid. We've saved the very best until... What are you laughing at, Michael?
They didn't show up, so you got us instead.
No, but honestly, I think if you work in the container world, or if you use Docker and things like that, which I'm assuming you do, you're here at DockerCon or you're tuning in on the video or whatever, and if you're interested in WebAssembly and what's potentially powering this next third wave of cloud computing, no pressure. I am expecting this to be quite a good session. Straight into it, though, to be fair. We're going to go along the line. So very quickly, I'm Nigel. I'm going to be your moderator. I am going to be slightly annoying at times because I am opinionated on a bunch of this stuff as well. So I will be potentially giving some of my own opinions on this. But my goal for this session is for... I want this to feel a little bit like we're in the hotel lobby tonight at the end of the conference, and we're just sat there and we're just riffing on, from our own personal perspectives, what we think is coming. I don't want this to be super formal or anything like that. Depending on how we go with time as well, I would love it if you have any questions or anything like that. I'm going to get to that point, hopefully. If you do, and you raise your hand, and I invite you to ask the panel a question, there's a standing microphone over there which thou must use for the video. Okay, please? So, without further ado, Matt, if you can introduce yourself, and then Michael, and then Timo, just pass the mic along the line. We'll hit the first question after that.
All right, I'm Matt Butcher. I'm the co-founder and CEO of Fermyon. We're building the next wave of cloud computing with WebAssembly. Fun fact about me, I've been in the container ecosystem for a long time and was the co-creator of the Illustrated Children's Guide to Kubernetes.
Wow, that's hard to follow up on. So I'm Michael Irwin. I'm part of the DevRel team at Docker. I've been with Docker for about 1.5 years, but even before Docker, I was one of the Docker captains for 5 years previous. So I've also been in the container space for a long time and love training, education, kind of breaking down complex things and making it simple for others as well. Yeah, that's me. Yeah,
and for whatever reason, I have a own microphone. I don't know.
You're special.
Yeah, okay. Maybe I cannot hold something and talk at the same time, maybe literally like this. Yeah, Timo Stark. I'm working in engineering and DevRel for Nginx and F5 networks. Yeah, I'm using Docker since 2017. I know that because that was my first DockerCon. And now I'm 2023 at Docker Captain. It's my first Docker conference as a Docker captain, and I'm pretty amazed to be here in this like high potential audience, to be honest.
Now, at a third-party company, you are implementing WebAssembly in some of the stuff that you do already, aren't you, Timo?
Yeah.
Okay, so you're like a user in the field. So I feel like we've got somebody who is building WebAssembly, you know, powering that third wave that we're going to talk about straight away, actually. We've got somebody from Docker who are doing really impressive things around it as well, or really interesting things for sure, and then somebody who's a practitioner, and then me who hasn't got a clue. So, but look, if you've been at DockerCon and if you've been at any of the other sessions so far, certainly any of the WebAssembly ones, there's this feeling that we're about to experience a third wave of cloud computing. Very quickly, the first wave based on virtual machines. Along came containers, powered a second wave. And a lot of people are thinking there's a potential third wave approaching based on WebAssembly. And I don't mind what order we take these, you know, who answers first or whatever. And you, as the three of you, you don't have to answer every question if you don't have an opinion on it. But I'm just curious what the general feel is from the panel around this notion of a third wave. Is it real? And if it is, how far away is it? And what do we think maybe it's going to look like?
Sure, I'll start. Yeah. I was going to like Rochambeau you for it, but you gave me the mic. So yeah, and you know, this is a big deal to us at Fermyon. We really feel very strongly that 2023 was the year that WebAssembly went from sort of a niche technology where we were exploring all the different things that could be done to us really having a strong understanding of the benefits of WebAssembly in the cloud ecosystem. And another thing we saw a lot in 2023 and are seeing is the standards bodies have moved very quickly now after moving very slowly for a few years. I think the net result of that is that we're seeing this kind of third wave motion. And we should clarify that, because we all agree on this. All four of us agree on this idea that when we talk about these waves, we're not talking about something replacing something before, right? When Docker came around and containers became a thing, there were those who predicted that it was the end of the virtual machine. Well, that clearly didn't happen. I think virtual machines are used even more now than they were then. And I think this is the same thing. We're finding niches, we're finding holes, we're finding things we want to be able to do with cloud computing, and and in each of these waves, at each of these phases, we're finding kind of a new way to solve it. WebAssembly, I think, is this excellent runtime for the kind of workloads where you need to start it up, run it to completion, and shut it down really fast, whereas containers still continue to be the way to do these long-running servers. And, you know, virtual machines, I think, are going to be around till the heat death of the universe. It's the only way to package up an entire operating system.
Yeah, and I'll echo a lot of that as well, too, because as part of my role in Docker, I do a lot of training and workshops with customers and training, education, developer communities within some of these accounts. And while we might, coming to DockerCon, you're kind of in the bubble, and you're hearing all things containers, and containers are going to change the world. But like in most of these environments, yeah, it's virtual machines are still everywhere. And so to come and say, hey, we've got the second wave and now the third wave, and WebAssembly is going to come. Yeah, it's not a replacement. Here's yet another capability, another possibility, another set of tools that are available for you to use in your different use cases. Of course, I love to say, hey, Docker and containers can be used for everything. But again, not everybody's ready for all shifts and all changes. And the last thing we want to do is say, hey, all the containerized stuff that you just finally got through, throw it all away. Now let's go to this WebAssembly thing. Like, it's just not going to work that way. But it's yet another opportunity, yet another tool for particular use cases, just like Matt was talking about here.
Yeah, especially the use cases thing. Because the way I see it is Docker made some use cases and some things, some processes a lot easier and a lot more efficient than just with raw VMs. But Docker did not replace a virtual machine at all. It was not doing it the last 10 years or the last 5 years. It will not do it in the next 5 or 10 years, I think.
I don't know. We might fight about this.
Yeah. But I think that adding WebAssembly to this third wave is similar. WebAssembly will be a better choice for specific use cases, for specific processes to make it more efficient, but it may not be the answer to a question, to all the questions, because it's like, I'm pretty sure we can discuss about it, but is it efficient to run a MySQL database management system in a WebAssembly module? Today, I have no idea. If you ask me, I would today say no, right? Put that in a container, leave it in a container, and do WebAssembly with things that are meant to be working WebAssembly, not put a whole database in it, right?
So I want to challenge some of this here, okay? Because I'm more of a believer that, yes, I know WebAssembly is not going to replace containers. We've established that containers didn't replace virtual machines. But I feel like the usage of virtual machines has gone up, like you said, but as a function of just the cloud in general growing. When containers were new, and I was like really early in there, and people would laugh at me, oh yes, containers, they're not going to be a thing, or maybe they'll be okay for stateless web servers. But now I've got people here, experts, saying that the container is where the MySQL is going to live. Well, rewind 6 years and people are like, MySQL in a container, this guy's off his rocker. So as things progress, look, no, we haven't replaced virtual machines, but containers, I feel like, and I'm going to ask for a show of hands here because I know not everybody is at the same point in their adoption journeys, okay? But I feel like for a lot of people, containers are the go-to solution for anything net new cloud native. Can I just get a show of hands in the room, and I'll try and help on the video. Who is already using containers as their go-to platform for new applications? Now, I feel like for anybody that's on the video, we're roughly at about 50% of the room there. Okay, there or thereabouts. So Do we think, given however many years, let's just call it 5, I've no idea, that WebAssembly will be eating into the traditional Linux container lunch? Anybody with an opinion? I don't mind who goes first.
You're handing me the mic. Okay, so I'm gonna start out by being really bold.
Yeah.
I think that the applications most likely to move from where they are now into WebAssembly are Amazon Lambda functions, Google Cloud functions, those kinds of things, because those are, they already follow a similar event-based programming model, and right now you're dealing with lock-in on those, you're dealing with poor performance on those, and you're dealing with basically having to choose at the beginning what kind of patterns you're going to use, and that determines where you can run these things from there on out. WebAssembly, I think, goes in and really levels the playing field there and says now we have an application model that can run in all these different environments. Now, of course, part of that is because that's very strongly what we believe at Fermyon, so that shouldn't be too surprising. The second part, though, I mean, there's always a sense in which when a technology comes out and kind of says, here's a different way you can do some of the stuff you've been doing. Some applications are going to migrate over. Some developers are going to choose that paradigm works better for them or that programming model works better. Others are going to choose not to. So I do think your challenge is rightly placed, right? That we will see some movement across the line, right? From a containerized thing to a WebAssembly thing. I don't really think that containers are the ones that run the most risk. I think it's Lambda function, Cloudflare workers, Azure functions, things like that.
Yeah, I just would like to add one thing, because I've spent a lot of time lately when it comes to extensibility of products. Yeah. Like, we heard a lot about Docker desktop extensions and how great that is to extend a feature of a given product like Docker desktop with some custom things like Docker desktop extensions. Same is for Nginx or F5 products. We have Nginx web server, we have an application server with Nginx unit, we have a bunch of other products, and people are always extended it with custom code, no matter, like, in Nginx it's a custom module, it's written in C. And it's not an easy thing. It's not something you will learn over a weekend to write performant, production grade, non-failing Nginx modules. This will take a couple of months, if not years, of experience to make it, to master this process. And I see WebAssembly in a spot where it can definitely help to make it a lot easier for people actually to enhance products at a specific point. For example, Nginx, what if we could enhance the request processing with custom code just by adding WebAssembly? Because the HTTP request, and that's what I made clear in my session, at the end, it's a byte stream. We have a couple of metadata in this HTTP request. We can send it to WebAssembly, and then you can write in whatever language you want something that handles this HTTP request. You do something with it. You send back a response, in quotes, from WebAssembly back to the processing host, which is maybe Nginx or Nginx unit or whatever. And then you do with the response, you move on with the request processing. So it makes it just easier to enhance this product. And I think for this specific use case, WebAssembly will be a very, very big player.
Yeah, and I'll jump into that as well, too, because, for example, when Docker first made its announcement of the Docker desktop and first experimental runtime and whatnot, and then we showed up to KubeCon just a couple weeks after, actually just a couple days later, it was interesting the number of people that were coming to us and talking about all the different ways that they're using WebAssembly. Because, for example, with this runtime, it's, hey, I can run this standalone container-like thing, and then we can talk more about how it's actually working later. But it's just a standalone running module. But also heard a lot of these other use cases as well of, hey, we're using WebAssembly, and here's a standard interface that if you want to extend our product, you write in whatever language, whatever framework, whatever tools you want, and as long as it can output to WebAssembly, then it can be ingested by that plugin architecture and that plugin framework. And I think one of the most famous use cases of this right now, at least the one that stands out in my mind, is Microsoft Flight Simulator. That a plugin's there, it's all WebAssembly now.
Right.
And so it's like a lot of the products are starting to build these plugin architectures that again, you write in whatever language, whatever tools, whatever frameworks your company is used to using, as long as it can output to WebAssembly, then it can be ingested by this plugin architecture, which again is a very different use case than I want to run this standalone WebAssembly module to perform some event-driven work or whatnot. So I think personally that's one of the exciting things about WebAssembly, that there's still so many different use cases for it outside of the browser. And in many ways, we're still trying to figure out what are all of those use cases, and how do we best support all those different use cases. So it's a really exciting time for it.
Okay, so I'm going to put a second challenge onto you from this first question, and then I promise we'll move on it and we'll compare and contrast a traditional Linux container that I think we understand with a WebAssembly module, so that we level set a little bit for where I want to take the conversation next. But what I'm hearing is that event-driven serverless stuff is a good fit for WebAssembly today. Totally agree. Timo and Michael talking about, okay, extensions and extending products and things like that. New use cases, really good. But I'm still just want to push just one last time. Let's say it's 5 years out, and as a general rule, a WebAssembly module is smaller, more portable, probably more secure than a traditional OCI container. Why would we not be moving more traditional workloads over to them? Like, I get it that we've got these new use cases and things, but if we've got something that's smaller, faster, more portable, and a bit more secure, why are we not going to then start moving over to that?
I mean,
I'm not taking the mic on that.
Yeah, Matt's like, don't hand me the mic on that. So, of course, this is just going to be my personal opinion here. And of course, this is kind of trying to read into the crystal ball a little bit. But like one of the things I've seen too is as we've been doing more training and more education on helping customers and companies even just adopt containers, like that's still the second wave that you were talking about. And change is hard. And especially with each of these waves of change, it's not just changing just one tool or how I do a CI/CD pipeline. Like, it's a cross-cutting change across the entire spectrum. It's changing how I do development. It's changing how I'm doing testing, even on my local machine. So all the inner feedback loop stuff is changing. How I'm building the application, how I'm packaging it, how I'm deploying it. Once it's deployed, how I'm monitoring it, how I'm observing it, performance metrics. Like, every piece of the entire software development lifecycle is being adjusted with each of these waves, okay? And in many ways, I think that's what's made, for many companies, the transition from traditional VMs to containers so challenging, because it's not just a tool change, it's changing all the processes, all the culture. It's a different mindset of how you do development, how you do deployment, and that takes time. And it's honestly one of the things I try to stress the most when I'm teaching people about, like, hey, welcome to containers, welcome to Docker. Give yourself some time. Let yourself iterate, let yourself evolve, and then continue to refine your processes. That's going to be the hardest part. So I think in many ways, that's going to be yet another challenge as we were looking at the next wave. Like, it's additional challenges of how do we now take this new wave of computing and how do we help people adopt that wave so when the tsunami comes in, it doesn't crash on them and everything. But again, it's these cultural changes, it's these process changes, it's mindset changes of how I do development, and that's some of the hardest changes to make within an organization.
Mm-hmm. Okay, just before you speak, Matt, I just want to sample the room again really quickly. You were going to give an opinion.
Oh, I was.
Okay. Yeah. All right, okay. I just want to sample the room really quickly. I understand that WebAssembly is bleeding edge, and this is maybe an advanced session, so isn't necessarily a great sample of DockerCon overall. But can I get a show of hands for anybody that is just at the beginning of their containers and Docker journey? Is there anybody in the room that's at the beginning? So we've got...
in the back.
Yeah, some people at the back. So it's interesting because I think quite often for us that are deep in this industry and have been for a long time, to forget that some people are just at the beginning of that initial containers journey, and kudos for being in the room where we're talking about the next wave already. No, but yeah, I think that's a really valid point, that there's quite a few people out there that are just starting with containers, and we're already talking about it. So please go on, Matt.
You can go.
Okay,
sure.
yeah. as I'm listening to Michael talking about a lot of that, it reminded me that there's kind of a higher level story here too. What are we trying to do with the cloud, right? And Brendan Burns, who is the creator of Kubernetes, I worked for him for a while at Microsoft, and he's very much visionary mindset when he built Kubernetes. And one of his favorite things to say early in the Kubernetes ecosystem was, you know, when we went to school, distributed computing was a 400 level class, right? And in the American system, that'd be the class you took your last year to get your undergrad degree. And he said, Kubernetes should make that a 100 level class, right? And I listened to that, and that was actually a really kind of profound statement. It took a little while to absorb it. What does he mean by this? Well, he means as we begin using the microservice design pattern whenever we can, as we begin composing applications into, you know, packaging them in Docker files, composing them into aggregate applications where all the chunks are separated and we do our separation of concerns very well, then it becomes much easier to accomplish the distribution of an application across the cloud, right? And consequently, we can build things that are more reliant and more robust and things that we can move around depending on the weather in the cloud, right? When something goes down over here, we run it over here. And WebAssembly is very much unlocking sort of a next degree of potential there, right? So Edge is a good example of this, right? If we're dealing with small, very portable applications, we can start moving them very effectively and efficiently within the proximity that's going to benefit the user the most. In other words, we can move the application so that the network distance they have to traverse is the fastest, or where the CPU is the best, or in the case of machine learning and AI, where there's enough GPU power to run those inferences as fast as possible. So I do think that if we look at things that way, from this kind of theoretical view, we can say, all right, we're kind of guessing at this point, right? We've got some ideas of what the future of distributed computing could look like, but we know that kind of at the heart of the cloud, that's what we want to build, right? And that's what we aspire to. So yeah, I mean, we could probably talk another 20 minutes or so about whether or not, you know, which pieces WebAssembly might take, you know, programming share away from this and what it might do over here. But it's this next iteration of what distributed computing is going to look like that'll really start to shape the way that we build this next kind of generation of applications that we're just now getting a glimpse at.
Right, yeah, and build is actually I think, a good point to start with what we just talked about, the WebAssembly component model, because we've now talked a lot about the way we can deploy, we can run, we can scale WebAssembly across the cloud, how easy it will be to run and operate WebAssembly things, binaries on the cloud, in the cloud, however. But the most interesting thing for me actually at the moment is, with the most potential as from a software engineering perspective, is the component model. Because on a very high level, it says that you write a piece of software, you deploy it and compile it to WebAssembly, and you follow the component model standards, so you can make use of other dependencies, but you're not, and this is new, this is totally new, you're not like locked in to this specific version, so it's likely a loosely coupled add-on to your software that can be exchanged, updated, fixed, vulnerability fixed, exchanged, whatever, without you having to recompile your actual piece of software. And this is, to me, that somebody who's doing software development for over 12 years, you're using dependencies every day. Like, even if they are your own dependencies or you use third-party dependencies from the open source community, that's great, but you use dependencies. And then you had like solutions from in Kotlin, Java, whatever, with Spring and dependency injection to make them testable, whatnot. But it's still a dependency. And if something changed in this dependency, you have to rebuild your application. We all saw there was Log4j 2 years ago, right? So that was basically a rebuild of the whole world. And with WebAssembly and the component model, this will potentially, and it will go away, that I can exchange components in this byte stream of different applications so that I do not have to know that this application or this WebAssembly component was fixed. I don't know, and I don't care. It's not dependent from, I use it, but I'm not dependent on it. So this is, to me, the most important thing.
And I can kind of throw in a quick example to make what you just said concrete. We had a really bad day when I worked at Azure one time when a library that 1,400 applications, 1,400 containerized applications had all imported, right? And so there's a 0-day exploit on this library, and of course that bubbles up, and it means we need to fix 1,400 applications spread across probably hundreds of different software development teams, and we needed to do it, all on that day. And that meant rebuilding all of these containers. One of the hopes of the component model, where we can split these libraries not just into separate blobs of data, but ones that are running in isolation in a security sandbox of their own and communicating across a host boundary. We could, in that kind of world, we could have said, all right, well, we're going to upload the new version of this library. Everything will automatically, on the next invocation of that program, right? The next time a request comes in or something like that, have been upgraded to that new version of the library, and we would have, the ops team would have saved hundreds of developer teams a day of engineering work in that case. We're also excited about the fact that in this world, the components can be written in a wide variety of languages, right? So suddenly we can be calling Python libraries from Rust code, which is called by JavaScript code, and which is used by Ruby or something like that. And that means we can finally stop duplicating the work where we have to do a YAML parser in every single programming language.
And one other aspect of that as well too is as these components are swappable. Maybe in production I'm using cloud provider-based components, while in my local development I'm using mock versions of those. And so then it opens up a whole nother level of development capabilities where, I can now mock, I can test, but my code base doesn't have to really change at all. And again, it just unlocks a whole nother world of possibility there.
I love that, actually. It's really good. Appreciate that. Thank you. Just one observation. I can't help saying this, okay? And this is coming from somebody who really likes Kubernetes a lot. And I mean no disrespect to Brendan or anybody in the Kubernetes community. Kubernetes sometimes makes me feel like we've taken distributed computing from a level 400 to level 500. Actually. And maybe
I won't disagree.
Now, very quickly, I know, I want to pivot quickly. Can anybody give us a very quick elevator pitch? And if we take too long, I'm going to have to shut you down and move on. But an elevator pitch on compare and contrast a traditional Linux container to a WebAssembly module. Just for us to level set for the next question that I've got. Does anybody want to take that?
To level set for a question we don't know that's coming. The
question that's going to come, so I'll frame this for you. Docker's done a lot of great work to help us run WebAssembly applications inside of containers. And I want us to go there and talk about what are the pros and cons of running WebAssembly in and out of a container. Yep. But before we do that, I think there's a level.
All right, yeah, so I can answer that. So when I run a container, first off, I've got to have the file system, basically all the files and binaries and config and dependencies, everything that needs to, at the end of the day, a container is an isolated process. Okay, so I need the file system for that process, and so that's what a container image is. I download the image, it gets unpacked, the union file system gets created and everything, and then a process is started using that file system. Okay, at the end of the day, a container is just an isolated process on my machine. That's it. Okay, where the WebAssembly modules are different is it's at the end of the day, it's leveraging the same distribution specifications that exist. OCI images, sure, it's a different formatted image and whatnot, but basically using that same distribution channel to say, hey, I've got now, instead of distributing an entire file system that has a bunch of files and binaries and everything else, I'm just distributing a Wasm module, and what's going to happen is when I run that Wasm module, it's like that Wasm module, you can't actually just run it by itself. Okay? Much like Java bytecode, I've got to have a runtime that can convert that bytecode into machine code and actually execute it. It's, it's analogous. Sure, they're structured very differently, but this Wasm module basically gets extracted out of the image and then dropped into a Wasm runtime that then actually does the execution of the Wasm module. Okay, so the actual runtime processing is actually quite different between the two, where again, a container, it's going to use the file system that's coming from the image, and it's running the process that's defining that image, assuming you didn't override the command. But a Wasm runtime, it's basically just using OCI to distribute, but then extracting it and then dropping it onto a Wasm runtime.
So quickly, if I can just add maybe, so would I be right in saying then that a Linux container is a collection of kernel objects, right? Kernel namespaces, things like that, that out of the box are quite wide open, but there's a lot of great work that's gone on to be able to lock things down, yeah? So kernel constructs that are kind of bundled together. Then WebAssembly apps run in a runtime that's outside of the kernel and is denied by default. So very different approach. Okay, right, so with that in mind, can we just talk a little bit about why are we packaging these in OCI images and putting them on OCI registries and like, do I get, because I'm very respectful for the great work that's been done that has really, you know, helped us securely run containerized workloads now. There's great work happened there. If we go WebAssembly inside of a container, am I getting double the security and things like that? Do I get the sandbox of WebAssembly, the security that comes with that? And then do I get all the C groups and capabilities and stuff as well? Like, I'm trying to figure out, like what do I get and what are the benefits of that? And are there any drawbacks?
Sure. So first off, so the first part of the question, why OCI in the first place? Pretty much the answer is like, why make another distribution mechanism? You know, we've already got something that already exists to be able to create packages, to distribute those packages, to, you know, there's RBAC already around it, to caching, and like there's so much that's already there. And in fact, at the end of the day, Wasm modules are just yet another artifact, but there's lots of other artifacts that are also being shipped in the same mechanism, Helm charts and various security policies, and I mean the list goes on. There's lots of different things that can be packaged up as these OCR artifacts. Wasm modules are just yet another one of at this point. So again, it was kind of just that we've already got a distribution channel. Tooling is already everywhere for it. Why reinvent the wheel yet again? And actually, in many ways, it's also kind of pushed the envelope to help support these new artifact types and help those specifications continue to. And it's still a growing specification there. It's definitely not finalized yet. So yeah, that's part one there. Part two. So again, when the modules get extracted out and are running on the runtime, as you mentioned, there's a lot of isolation mechanisms that already exist in that runtime. Matt can probably talk a lot deeper about this as well. But like, for example, if you're running WebAssembly in your browser, well, you don't want the WebAssembly that's running in tab A to be able to affect tab B and tab C and whatnot. And so the browsers, they've got that baked in, and they've got a lot of those isolation mechanisms, and they don't want you to be able to modify the file system, and it's a very controlled environment. And in many ways, it's like that same environment now just in other environments where there's that isolation mechanism. Now, in Docker, and Georgie, feel free to correct me here, but I'm pretty sure we're not running those runtimes in a container. That's correct, okay. We are? Okay, so yeah, the runtimes themselves are running in a container so that the runtime is leveraging those kernel namespaces and control groups and everything. So there's the runtime running as a container, but again, as I'm running the Wasm module, it's being extracted and then put into that runtime there.
Okay.
Oh yeah, I can add color to kind of both of those. Yeah, actually, I'll stick to the OCI one because so OCI images, right? With the things we push and pull from Docker Hub. I had kind of like one of those sort of gestalt shift moments where I had for so long thought about those as just being used to do, you know, the layer diagrams that you need to reconstitute a file system. And then at some point, you know, the kind of bit flipped, and I'm like, oh, this is a way to store a list of very closely related things that the runtime knows how to deal with, right? And that was the artifact specification for OCI, which is a specification that sort of generally describes how to store arbitrary artifacts in an OCI registry. That specification really kind of made it possible for us to say, okay, across all different registries, we're not going to need to necessarily limit the registry to only being able to store Docker images. Suddenly we can put Helm charts in there. We can then start putting in, I think if Olama is using it to store large language models and additional prompts and all kinds of things. I mean, it's a very interesting way of doing things. And then we at Fermyon now, we write our applications in there. So we may have a Wasm module sitting at each entry inside of the layer diagram. This turns out to be a really profoundly good way of getting all the Merkle tree SHA goodness where we can verify that the application has been modified, all the signing stuff that has been popular in the last few years for software supply chain, the distribution mechanism, the fact that every major cloud provider already supports all of this. We get this wealth of ecosystem goodness merely by saying, yeah, we can store our thing in that format too. It took me a little while, admittedly, to get there because, again, because I was thinking of it in terms of how it was originally built. But I think one of the coolest things about a technology is when you build something thinking it's going to do this, and then other people come along and say, wait, it can do this and this and this, and you go, oh yeah, you're right. And I think OCI has definitely, the OCI registry format, Docker Hub, all of those have definitely been in that camp.
Very quickly, guys, I've just got an eye on the time, okay? I want to ask a couple of quick questions if we can be as quick as we can with them. Yeah. Does anybody, before we go with that, have a question that they would like to ask? And we'll try and park a couple of minutes at the end. Just raise your hand if you do. You don't have to. I'm going to say no. Okay, all right. So bear in mind that I think the future for WebAssembly and containers is at least broad enough for us to have WebAssembly running outside of containers successfully in lots of ways, and WebAssembly running inside of containers successfully in lots of places. Is there anything obvious that we would lose, or that we do lose, by running inside of a container? Because I think we've established we get a lot of great stuff. We can work with the existing Docker tooling that we all know, okay? We can use existing OCI registries and other infrastructure and stuff like that. But is there a downside to doing it that way?
I know one immediately. So, I mean, we have dealt with one as we've started doing more work in AI with LLMs, and that is the low-level GPU implementations, right? If you're going to do fast AI, generative AI, you need very good access to the hardware accelerator. In WebAssembly, we have this very nice abstraction layer where we can say, okay, you as a developer can write your code and it can call the function llm.infer, and you don't have to know a thing about the architecture that's running underneath the hood. But the WebAssembly host runtime will know, which you don't have to worry about at all. It's the piece of software that your WebAssembly is running on. That thing will know about what the hardware underlying the system is, how to make the best use of the GPU, and so on, right? Until this morning's announcement, I thought this was actually not something that a Docker, if you containerize it, you would not be able to do terribly effectively. Docker does not have great support for a broad range of GPUs yet, and I wasn't really sure how that could be solved in a generic format. If you were at the last part of the one more thing in the keynote this morning, you saw that Web GPU is something that Docker is looking at utilizing as an abstraction layer. So that, you know, the one thing that I would have emphatically stated this morning, yeah, if you containerize it, it's not going to work as well. I think I have to backtrack on a little bit, at least until we see how that plays out. But I think there is the thing that my view of this is, well, yeah, you could put it in a container, but you don't need to put it in a container. You can put it in, you know, any number of runtime environments, but you're not really getting any benefits. So if it works well for your environment to containerize it, and actually, Timo, when you did your demo today, you containerized both Unit and the WebAssembly application so that you could run the WebAssembly application in Unit. That was a really good use of containers proper, right? In the demo I did, we packaged just the WebAssembly file. We ran it in the containerd shim, which is outside of the container boundary, and that was just another way of doing it. Both of our demos ran quickly and did what they were supposed to do. So, you know, in a sense, I don't know if you're getting anything or losing anything in that one.
But yeah, the most important thing is it works inside of the ecosystem. And what you just said, the OCI model, the registries, and what we heard, that there are people that are just getting started with the container journey. And I was working long enough for a big German automotive company. I'll tell you, if it is very hard for them to move this VM-based architecture. Talking about VM-based means like over 10,000 virtual machines in an on-prem data center. I was long enough the sysadmin of those things. And I was basically the first person who installed a Kubernetes cluster for them, right? So in this migration from a whole VM-based operational process to something that is Kubernetes and containers with all the things that come with it is hard. It takes a long of time. It is not cheap in terms of money you have to spend to like increase knowledge, to create knowledge, and then operate all these things. And if we say now, look, containers are dead, now WebAssembly is the new shiny thing, and we just do this, like after 6 years or 7 years, they will not jump on this train. Definitely not. And from my perspective, from somebody who implemented a WebAssembly runtime in an application server, actually that sounds like a very stupid idea right now when I'm saying this. Right. It was amazing, and it's still very, very, very cool. And it was a great journey, but now I have more possibilities. And adding this to the already existing ecosystem of Docker is an enrichment to this whole thing. It's not a replacement of something. And now we have to find, and this is, I think, the challenge for the next years, we have to find the use cases that work well with WebAssembly, that maybe not work super well with WebAssembly, where WebAssembly works well in a container, where WebAssembly should be hosted better on a VM or on another host, however that might look like. So yeah, to me, these are the challenges we have for the next couple of years.
So maybe just one quick thought. One of the questions that I got a lot when we first announced the first container runtime at KubeCon was, okay, what's this look like in Kubernetes? Like, should I be deploying my Wasm modules and using a WebAssembly class runtime and all this kind of stuff? It's like, sure, you could, but yeah, I mean, as Matt was talking about, the whole point is quick startups and quick runtimes and a lot of the event-driven systems. And those environments, Kubernetes may not be the right orchestration system for that as well, too. So in that case, it probably doesn't make sense to be like, hey, I'm going to deploy all my Wasm modules using Kubernetes, because it's kind of, they're solving different purposes.
Sure.
And for the last 3 minutes, one thing that is to me very, very important is, we talked a lot about standardization. And I mean, while we're sitting here, for example, like we from F5 and Nginx, and me as a person, Matt as a person, and Fermion as a company, we have a lot of talks lately because we would like not to reinvent the wheel. It doesn't make sense if we create another structure that is not compatible with, for example, WASI HTTP, and Fermion create a lot of stuff that is compatible with WASI HTTP. And this is this piece of standardization where I think we can do, or we have to do a good job for the next years to find a standard saying, hey, if you would like to export an HTTP interface from your WebAssembly module, this is the way to go. This is the structure you have to use, no matter the runtime. If it's a Fermion spin thing, if it's an Nginx unit F5 thing, if it's a Docker thing, it doesn't matter. If your WebAssembly module will work or should work with an HTTP interface, this is the way to go. Okay. Right? So
super. Thank you. I'm going to ask just Matt here, if you don't mind, and I'm so sorry to put you on the spot, or single you out, Matt. And
I don't have to sing, do I?
Yeah, no. Okay. Yes, please. No. Just because you're CEO of a WebAssembly startup and you live and breathe it all the time, just 1 minute, could you give us what you think we should expect to see in the next 12 months in this space?
Oh, sure. Yeah, that's an easy question for me. I do live it.
That's
yeah.
what I mean.
I think there are a couple different avenues to start with. So I'm going to pick up right where Timo left off. Standards. WebAssembly is standardized by the W3, the same standards body that does HTML, CSS, the big standards, right? 2023 has been a year where we've seen a lot of momentum on a lot of different standards, including better memory management, networking, all of these low-level things like the component model. We're going to see all of that stuff really come to fruition, I think, in the next 12 months. I really feel like things have hit that kind of level of velocity where stuff is getting done, reference implementations are being written, and things are rolling into WebAssembly runtime. That means the number of features is going to go way up. It reminds me of there was this period in Docker where it was like every couple of months it was like, oh, look, another cool thing is ready. Oh, look, this does this now. And we're going to see that happening both in the standards and the implementations of those standards. The other thing is, I've seen hesitancy that WebAssembly was maybe too new of a technology this year. But now we're starting to see people begin to use WebAssembly in production, particularly I see it for the serverless functions, right? And that for sure is going to roll out. And then the last one is just WebAssembly and AI, the technology underlying LLMs and the technology that WebAssembly provides to the developer, these two sit very much like a layer cake and frosting on top. And I really think that because of that, we're going to see a lot of momentum around that in the next 1 year.
Thank you. 10 seconds left. I want to know if the lights go off automatically. No, I'm just kidding. So look, on behalf of everybody on the panel, can I just thank you all for coming out? It's the last session of DockerCon. Personally, I'd like to thank Docker Inc. for organizing and running DockerCon. I think I speak on behalf of a lot of people. It's been a fantastic event. But can I just ask everybody, for the 3 panelists here, can we give them a really warm round of applause, please? So everybody, safe flights home, journeys home, card rides home, whatever you're doing for the rest of the evening, go and enjoy yourselves, and thank you.
Thanks all.